Question number 1. LCM and HCF of two numbers are 144 and 12 respectively. If one of the number is 36, then other number is option A 40, option B 24, option C 48, option D 80. LCM and HCF of two numbers are 144 and 12 respectively. Okay. So let A and B two numbers. Okay. Let A and B be two numbers. Given that LCM of A comma B equal to 144. Okay. And HCF of A comma B equal to 12. Then what is given? If one of the number is 36, let A equal to 36. Then other number is, so question is to find out the value of B. Now we know that LCM of A comma B into HCF of A comma B is equal to product of two numbers, that is A into B. Here LCM is 144. 144 into HCF is 12 is equal to one number is 36. 36 into B. This one we can write it as 36 into B is 36B is equal to 144 into 12. Therefore, B is equal to 144 into 12 by 36. 12 into 3 is 36. So, B is equal to 48. Answer is option C 48. Second question. If the HCF of 65 and 117 is expressible in the form 65m minus 117, then the value of m is option A 4, option B 2, option C 1, option D 3. If the HCF of 65 and 117 is expressible in the form 65m minus 117, means HCF of 65, 117 is equal to 65m minus 170. Okay. Here numbers equal to 65 and 170. Okay. First reduce the numbers into its factors. Okay. Do the prime factorization. So 65 equal to 5 into 30. 5 into 30. 117 equal to 3 into 3 into 30. Okay, that is 3 raised to 2 into 30. Next, HCF of 65, 117 equal to, now what is HCF? HCF is the product of the smallest power of the common factors. So which all are the common factors? 5. 5 is not a common factor. 13. Isn't it now? So 13. 3 also is not common. And powers are same. Here also 1, here also 1. So 13. 13 is the HCF of 65, 117. Okay. And it is given that it is of the form 65m minus 170. That is 65m minus 117 equal to 13. Now 65m is equal to 13 plus 117. 13 plus 170 is 130. Okay, that is 65 m is equal to 130. Now m is equal to 130 by 65. Now 65 into 2. 5 2s are 10. 12 plus 1, 30. Okay, so 2. 1. So value of m is 2. So answer is option B, 2. Next question number 3. If x equal to 2 raised to 3 into 3 into 5 raised to 2, y equal to 2 raised to 2 into 3 raised to 3, then LCM of x is option A 4800, option B 1080, option C 5400, option D 3600. Given x equal to 2 raised to 3 into 3 into 5 raised to 2, y equal to 2 raised to 2 into 3 raised to 3. Next, find out the LCM. LCM of x comma y. What is LCM? LCM is the product of the highest power of each factor involved. First factor 2. Which one is the highest power? Here 2 raised to 3 and 2 raised to 2. 2 raised to 3 is the highest power. So 2 raised to 3 into 3. Here power is 1. Here 3 raised to 3. So 3 raised to 3 into 5 raised to 2. Sorry, question is to find out the LCM of x comma y. Okay. Now multiply it. Okay. We know that 2 5s are 10. Here 2 raised to 3 and 5 raised to 2. 2 raised to 3 we can write it as 2 raised to 2 into 2. Okay. Into 3 raised to 3 into 5 raised to 2. Okay. That is equal to 2 raised to 2 into 5 raised to 2 into 2 into 3 raised to 3. That's equal to 2 into 5 whole raised to 2 into 2 into 3 raised to 3. 3 into 3 9, 9 into 3 27. That's equal to 2 into 5 10. 10 square into 2 into 27 is 54. That is equal to 10 raised to 2 is 100. 100 into 54 equal to 5400. 5400. So LCM of x comma y is 5400. Next question number 4. If p comma q are two coprime numbers, then HCF of p comma q is option A p, option B q, option C p q, option D 1. What is coprime numbers? Two numbers that have only 1 as the common factor are known as coprime numbers. So if p and q are coprime numbers means p and q have only 1 as the common factor, right? Now what is HCF? HCF is the product of the smallest power of the common factor. Now here p and q have only 1 as the common factor. So HCF of p comma q equal to 1. Okay, that is HCF of two coprime numbers is 1. Question number 5. Which of the following rational number is terminating decimal expansion? Option A 17 by 450, option B 23 by 360, option C 31 by 70, option D 51 by 300. What is the condition for terminating decimal expansion? The factors of the denominator is of the form two raised to n into 5 raised to m. First step, the number should be in the least form. After that, do the prime factorization of the denominator. Okay, consider the first number, first option. 17 by 450. 17 by 450 is in the lowest form. Now do the prime factorization of 450. 450 equal to 2 into 3 into 3 into 5 into 5. That's equal to 2 into 3 raised to 2 into 5 raised to 2. These are the factors. So it is not in the form 2 raised to n into 5 raised to m. So neglected. Now consider the second option, 23 by 360. 23 by 360 is in the lowest form. So next do the prime factorization of the denominator, that is 360. 360 is 36 into 10, isn't it? That we can write 36 prime factors are 2 into 2, that is 2 into 2 into 3 into 3. 10, it is 2 into 5. That's equal to 2 raised to 1, 2, 3 into 3 raised to 1, 2 into 5 raised to 1. Here also factors are not in the form 2 raised to n into 5 raised to m. Now consider the third option. Option C, 31 by 70. First step, make it in the simplest form. Here 31 by 70 is in its simplest form. Now do the prime factorization of the denominator, that is 70. 70 is 7 into 10. That is 7 into 10 is 2 into 5. Okay, here also denominator is not in the form 2 raised to n into 5 raised to m. Now take the option D, 51 by 300. Okay, it is not in the lowest simplest form because 3 is divisible by both numerator and denominator. So divide by 3, it is 1700. Okay, that is 17 by 100. Now write the prime factorization of the denominator. Denominator is 100, that is 10 into 10, that is equal to 2 into 5 into 2 into 5. That's equal to 2 raised to 2 into 5 raised to 2. That is denominator is in the form 2 raised to n into 5 raised to m. Isn't it now? So therefore 17 by 100, that's equal to 51 by 300 is terminating decimal. So answer is option D. Next, question number 6. If a comma b are co-prime, then a square comma b square are option A co-prime, option B not co-prime, option C odd numbers, option D even numbers. Now what is co-prime number? Two numbers that have only one as the common factor is known as co-prime numbers. Consider an example, okay? Let's take two prime numbers, 2 and 3. Because we know that prime numbers are co-prime to each other. Here 2 and 3. 2 and 3 are co-prime numbers because they have only one as the common factor. Okay. So let A equal to 2 and B is equal to 3. Now question is to find out the value of A square and B square, isn't it? So A square is equal to 4 and B square is equal to 9. Okay. Now 4 factors. 4 is equal to 2 raised to 2 and 9 is equal to 3 raised to 3. Sorry, 3 raised to 2. Again 4 and 9 have only one as the common factor, that is 4 and 9 are co-primes. That is if 2 and 3 are co-prime to each other, then 2 square and 3 square are also co-prime numbers. That is, if A comma B are co-prime, then A square comma B square are option A, co-prime. Next, question number 7. Euclid's division lemma states that if A and B are any two positive integers, then there exist unique integers Q and R such that option A equal to BQ plus R, 0 less than R less than B. Option B, A equal to BQ plus R, 0 less than or equal to R less than or equal to B. Option C, A equal to BQ plus R, 0 less than or equal to R less than B. Option D, A equal to BQ plus R, 0 less than B less than R. It is option C, because R 0 less than or equal to R can be 0. 0 less than or equal to R less than B. Next, question number 8. The decimal expansion of the rational number 27 by 2 raised to 3 into 5 raised to 2 will terminate after how many places of decimals? Option A 2, option B 3, option C 4, option D 5. Consider an example, okay? Find out the decimal expansion of the rational number 123 by 10. Okay, so answer is 1, 2, 3. Here in the denominator only 1 0. So after decimal only one digit, that is 1. After decimal only one digit. Okay, similarly 123 by 100. 1, 2, 3, 123. Then here in the denominator 2 zeros. So after decimal 2 digits. So 1, 2. Point is 1.23. Next 123 by 1000. 123. Now here also, here in the denominator 3 zeros. So after decimal 3 digits. 1, 2, 3. Answer is 0.123. So if the denominator is 10, 100, 1000, etc., then it is easy to find out the decimal expansion of the rational number, right? And here in the denominator 2 and 5 are the factors, and we know that 2 into 5 is 10. Here 3 2's and 2 5. Okay, so first step, multiply both numerator and denominator by 5. That is equal to 25 into 5 by 2 raised to 3 into 5 raised to 2 into 5. Okay, that is equal to 27 into 5 by 2 raised to 3 into 5 raised to 2 plus 1, 3. Okay, that's equal to 27 into 5, 135. 2. This one we can write it as 2 into 5 whole raised to 3. That is 135. 2 5s are 10. 10 raised to 3. That is equal to 135 by 10 raised to 3 is 1, 2, 3. That is equal to 135. 3 zeros. So 3 decimal after point, 3 digits after point. 1, 2, 3. Answer is 0.135. So the decimal expansion of the rational number 27 by 2 raised to 3 into 5 raised to 2 will terminate after 3 decimal places. Answer is option B. Question number 9. The prime factorization of 3825 is option A 3 into 5 raised to 2 into 21. Option B 3 square into 5 square into 35. Option C 3 square into 5 square into 17. Option D 3 square into 25 into 17. Okay, do the prime factorization of 3825. 3825 equal to 3 into 3, that is 3 raised to 2. 3 square into 5 into 5. 5 square into 17. 3 raised to 2 into 5 raised to 2 into 17. That is option C. Question number 10. For the decimal number 0.6 bar, the rational number is option A 33 by 50, option B 22 by 3, option C 111 by 167, option D 1 by 3. This type problem you already studied in class 9th, right? So here number is 0.6 bar. Okay, that is 0.6. 6 is repeating unit, isn't it now? So write numerator equal to 6. 0.6 bar means 0.666 like that, isn't it now? So how many repeating digits are there? Only 1. So denominator equal to 9. Okay, answer is 6 by 9. Next, convert into its lowest form. 6 by 9, 3 is divisible, right? 2 by 3. So option B, 2 by 3. Okay. Now consider another example, 0.23 bar. Okay, 0.23 bar means 0.23, 23, 23, etc. Okay, so here numerator is 23. This is equal to 23 by how many repeating digits are there? 2, right? So 23 by denominator is 99.